สวัสดีครับ My name is มัทมากรจารุพยพันธ์ Today I'm going to be presenting to all of you about the turbocharger to let you know how the turbocharger works and many types of the turbocharger to let you know how different they are. Okay, this slide is made up for the SC135 subject. Okay, let's begin. So this is agenda to show all the subjects that I'm going to present to all of you. Okay. First of the subject, state of art and motivation. Okay, this slide. I'm the one who made up as a case study for the turbocharger. Okay, let's talk about nowadays or 2020. We have seen so many cars with the turbocharger up from 1000cc to 7000cc. Turbocharger. What is turbocharger? Turbocharger had the duty to boost more air into the combustion engine to drive the car forward. The motivation of this subject is to show how the turbocharger works. Cars with turbo engines are in great demand now and are favored by more and more people. Okay, let's talk about the objective. I'm a student who study in the automotive engineering right now. To understand how the turbocharger works, it is one of the significant knowledge for engineer. Okay. A turbocharger is a fuel-driven turbine aimed at air compression with the purpose of increasing power and torque of the engine. If you want a more powerful turbine, you should consider piecing together air compression and density increase. It enables the engine to have more oxygen per burn. The energy release is directed to the piston, which moves compressed air. This leads to greater amount of air and fuel within the engine. Thus, you can enjoy much speedier car and get more pressure from driving. This project is presenting pros and cons, or advantages and disadvantages, and how to develop turbocharger in the future use. Okay, background and problem statement. Okay, there are 7 types of turbocharger. First, second turbocharger. Second is dual turbocharger. Third, twin scroll turbo. Fourth, variable geometry turbo, variable twin scroll turbo, and electric turbo. Okay, when did the turbocharger have been introduced to this world? It began in 1905 by a Swiss engineer named Alfred Bucci. Okay, Alfred Bucci is Swiss. Okay, he was originally born from Switzerland, and this guy has made the turbocharger for the use of the marine or the submarine, to drive the submarine forward. In order to not lose any more fuel consumption, he created turbo to move the submarine forward without any loss of the fuel. Okay, single turbo. Wow. There are many cars nowadays that use a single turbo. Let's talk about the pros of this turbo. Single turbo are also worth of being taken into the consideration. If you need a perfect car for drag driving, you should consider single turbo, as it is the best option when you need high amount of power. Having power on one side, you would have to deal with the lack power on the other side. Lack power, or what we call in Thai is turbo delay. It is much easier to set up a single turbo than a double one. It is smaller, compact, take much less space than a twin turbo. Okay, this will save a lot of your cost, cause a single turbo not worth very much, and it's compact. Take much less space than a twin turbo, which means it won't weigh your car anymore. Second, twin turbo. Okay, why twin turbo has made up instead of the single turbo. Twin turbo made up for uh, reduce the turbo ragging. Okay, how do you know that the twin turbo and single turbo appropriate for any engine? Okay, let's talk about this. Twin turbo setup provide for the reduction of the lag. It helps produce power faster by using 4-cylinder, while single turbo require or 8-cylinder for optimal boost. This type of engine is greater for regular driving in the city or normal resuming. Resuming is like an urban area, yeah, which means you can drive ในเมืองหรือต่างจังหวัด something like that. Okay, twin turbo take care of smooth engine functioning. In terms of expense, two small turbochargers are more efficient than one big one. However, some engines require twin turbocharger for better and more efficient operating. Okay, we're gonna talk about the disadvantage of it. The disadvantage of the twin turbo is that it makes a lot of cost to make a twin turbo and take a lot of the space, and it will weigh the car much heavier. Okay, let's talk about the third one. Twin scroll turbo. What is twin scroll turbo? Okay, let's check. It's very easy to understand. Okay, the left picture is a single turbo, and the second is twin scroll turbo. It sounds like a twin turbo, okay, but it's not. It's a single turbo that has a two hole. These two hole, what do we make for? Okay, these two hole in order to bring the air into the turbo or into the turbine. Yeah, this thing will reduce a lot of cost than the twin turbo because of the two scope. Okay, the spiral channel to the turbo is called scope, and there are two of them, one impeller, so twin scope cylinders are matched up based on when they fire. In our hypothetical engine where cylinder 1 and cylinder 2 overlap, cylinder 1 exhaust would be paired with the cylinder 3 in the first scope and 2 with 4 in the second scope, so there is no overlap. Then each of the matched exhaust stream take a separate path to the turbocharger. They both spin the same wheel but don't really mix. Okay, let's talk about the advantage. There are advantages are increased low end torque, improved boost response, rise power throughout the power band, maximize turbine efficiency, reduce engine pumping loss, improve fuel economy. Oh, increase fuel economy, which means you're gonna save your fuel and more range to drive the car. Okay, there are also disadvantages about twin scope turbo, which means that it had a poor efficiency at high engine load and speed, compact, expensive exhaust manifold and turbine. Okay, what is expensive exhaust manifold? Okay, I'm going to show you the picture. This is manifold, or what we call header, or inside we callท่อ ID. Okay, why is it expensive? Which means that you have to redo all the manifold all over or renew to do over again. Okay, right side is for single turbo. Yeah, which means that you have to do the front plate or new again to match the twin scroll turbo. Okay, fourth one, variable geometry turbo. What is the difference this is the difference. The difference is here, the metal plate. There are many metal plates of the variable geometry turbine. Okay, let's take a look at the picture. Variable nozzle and turbine bed. Turbine bed here. In other words, we call the compressor turbine. Okay, as the air go in, the variable bed, the variable nozzle start to spin faster. Yeah. Okay, let's talk about this. Perhaps one of the most exceptional form of turbocharging, VGT or variable geometry turbo, are limited in production through very common in the diesel engine, which means that this common turbo has been appear on the diesel engine mostly as a result of cost, exotic material requirement, internal vents within the turbocharger altered to the area AR ratio to match the RPM. RPM is stand for round per minute. At the row RPM, add a row area to radius is used to increase exhaust gas velocity, quickly speed up the turbocharger. Okay, let's skip and talk about the result. The result is low turbo lag, a robust threshold, and a wide and smooth torque band. Seems like it's an advantage of it. Okay, it's wide fat torque curve, effective turbocharging at a very wide RPM range. It requires a single turbo, simplifying a sequential turbo set up into something more compact. Okay, let's talk about the disadvantage of it. For the gasoline application, costs typically keep them out at exotic metal. To have used it in order to maintain reliability, the tech has been used on the Porsche 997. Through very few VGT gasoline engines exist as a result of costs associated. Typically only used in the diesel application, where exhaust gas are lower so the vent will not be damaged by heat. Okay, so variable geometry turbo mostly appear in the diesel engine because of, as an example of Porsche 997, it will take a lot of cost to put this turbo to match the engine. You need a lot of money to buy all the parts to use it and match it with variable geometry turbo. Okay, let's talk about the next one, variable twin scope turbo. See, so from this picture you will see that there are two geometry turbo has been used in variable twin scope turbo. This thing have been made up for a while, and this thing has made just for use the twin scope turbo and variable geometry to make it together, and it's become variable twin scope turbocharger. Okay, a twin scope turbocharger has a vent which can redirect exhaust airflow into just a single scope, or vary the amount the valve open and allow for the gas to completely split between the two scopes. Okay, let's talk about the props of it. Significantly, it's cheap. Wow, it's cheaper than the VGT, variable geometry turbo, thus making an acceptable case for the gasoline turbocharging. Allow for a wide, flat torque curve, more robust in design versus a VGT, depending on the material selection. Let's talk about the cost, and complexity. Compared to the single turbo or traditional twin scope, which means that it will take a lot of money to use this turbo to match your engine. The technology has been paved with before, quick spoon valve, but doesn't seem to catch on in the production of the world. There are likely additional challenges with the new technology. Okay, this thing is very special. Electric turbocharger. What is electric turbocharger? I'm going to show you how this thing has introduced to this world. Electric turbocharger. Electric motors are undoubtedly become a larger and more important element of the automotive propulsion landscape with each passing year, directly supplying torque to turn the drive wheel is most obvious use case in a hybrid and electric vehicle, but most are turning up everywhere, including oil and coolant pump, and now turbocharger. Okay, Garrett Motion give birth to electric turbocharger to let us know how this thing is going to work. This thing have 6 combination: turbo housing and turbine wheel, this one, center housing and electric motor, this one, compressor housing, this one, and compressor wheel is the billet, and wastegate actuator and control unit to use combination with the electric power. Okay, we're going to skip and talk about the advantage of it. By directly connecting an electric motor to the compressor wheel, turbo lagging and insufficient exhaust gas can be virtually eliminated by spinning compressor with electric power when needed. This thing is going to kill all the turbochargers that have been made because of the anti-lag, and insufficient exhaust gas will be eliminated, which means that it will save the fuel of the car. Yeah. Okay. It's also, this technology have been using in the Formula 1 for years. A very wide effective RPM range with even torque throughout. Okay, we're going to talk about the disadvantage of it. Oh, the cost again. Why this thing is expensive? From the news of the electric turbocharger, this thing approximately costs about $50,000 to buy one of the electric turbocharger, and even more is compact. As you know now, must account for the electric motor and ensure it remains cool to prevent reliability issue. That goes for the air controller as well. Packaging and weight become an issue, especially with the additional of the battery on board. Seems that it has a lot of disadvantage because of its cost. Okay, related word. So, not very much, because of its innovation that just discovered and prepared to produce in 2021, which means that in the future or next year, this is 2020, next year Garrett Motion is going to produce electric turbocharger through all the industry of the automotive car. So this new show that electric turbocharger have been using in Mercedes-AMG team of the Formula 1. Okay, Mercedes is taking more of its F1 research from the track to the street. Mercedes has been using electric turbocharging on its F1 car for a few years now, and is confident it will be able to implement it on the road car, which means that Mercedes-AMG team is very sure about the future, that electric turbo that can be happen in the future that can using with the normal car on road. Okay, this showing how purpose work and maturity of my subject. So situation here right now, as there are many of the turbochargers in 2020, electric turbo just introduced by Garrett Motion is a new technology to change the world. So the solution here, electric turbocharger has the duty to change the world by their benefit are down speeding, downsizing, and high efficient aerodynamic. Okay, there are 3 steps that I'm going to solving step by step. Okay, first one, we need to understand of how the system works. Second, we can distinguish type of turbocharger. Third, adapting type of turbocharger for appropriate use of the engine. Okay, sorry. Benefit of it, improving knowledge skills, electric turbocharger can reduce emission. The obstacle of this subject is that the cost of the electric turbocharger is super high. And second is, it would be difficult to do experiment on the AV turbocharger because it needs to find appropriate engine to test with it. Oh, system architecture. So this one show about the system of the turbo. How the turbo work? Okay, first step is here. The air driving into the compressor inlet, and this thing will drive to the compressor discharge to the charger air cooler to the intake manifold to the engine. After the engine combusting, exhaust and the gas will pass to the exhaust manifold to the turbine inlet and out to the exhaust. So this is how it looks like, the architecture of the twin scope turbo. There's a top here that look different, but the inside is all the same. Yeah, it's the inside. Okay, this one, electric turbocharger. We can see that from here, the people accelerating more, the air take more, and the valve gate open because of the exhaust needs to be out. Here is a electric control and the battery that need to be used of the 48 volt to combine with the electric turbocharger. Okay, system design. This is design that show the system of electric turbocharger. So how the turbocharger work? Here is the e-booster or turbocharger, or the electric turbocharger. Here is a bypass valve, and here is a wastegate valve. So experimental results show that this graph shows the electric turbo combination with the engine of BMW N54 turbo compressor working different with exhaust compressor. This will help to cool down the temperature intake manifold heavily. This result will make the car to show its peak of its performance well. Here, the graph. Different boosts go. You can see that the blue line using 8 psi. You can see that the graph is continuing to go up, which means that 4 different boosts, this car that use the electric turbo will never have the lack of the turbo, and it will self-fuse. Okay, this will be much easier to understand. We accelerate more, the engine go up, and here is that when the turbo is starting to be up high, the boost go up, boop, 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 same as the acceleration go on. Here it means that when you lift off the pedal, it's starting to have the lag of the turbo, and when you pedal more, it will do the same thing that it just happened just now. Okay, system analysis. what physics if what physics what physics equation can use in this type of turbo? So we just use the wind power equation to calculate the power. Second, we use the power law at the kinetic energy. And third is the turbine. We can use two of these equations to calculate the mass of the air flow to a wind turbine or the power. Here is the binary equation. This equation is happened in the thermodynamic or fluid to show that how we can calculate the from the front tunnel to the second tunnel. Okay, conclusion about this one. I hope this project will be helpful to all readers. This is gathering all the information about the turbocharger. All the type has different duty to operate and distinguish easily. I hope in the future and the work might be useful to everyone. Thank you. Okay, let's talk about the system demonstration. Okay, phase 1 of the electric turbocharger. Vehicle and engine running at a low load and a constant speed. Okay, we can look at here the bypass valve. Here bypass valve is closing because driver drive the car at a low speed, but the turbocharger is working. Second, the driver push accelerator pedal immediately respond for more boost. Here bypass valve has opened and the air starting to come in. Yep, to drive motor car faster. And phase 3, turbocharger take over, providing higher boost pressure than the e-booster, which means that the e-booster is not working right now because on the second phase just now, this thing is helping the turbo to work more efficiently. Okay, thank you for all of you guys to listening about my project presentation. Thank you. ขอบคุณครับ